this video is for section 1.6, and it's also kind of an introduction to sections 1.6, 1.7, and 1.8. All of these sections are talking about rational expressions, which is another name for algebraic fractions, okay? And then section 1.9 is about rational equations, which are equations that involve algebraic fractions, okay? So we're getting started. We're getting ready to start doing a lot with these algebraic fractions. So the first thing, first off, let me tell you what we're going to do. We're going to do all the things that we do with fractions. We're going to reduce them. Okay. We're going to multiply and divide them. We're going to add and subtract them. And then, let's see, section 1.8 gets into this issue of fractions within fractions. And then section 1.9, like I said, involves solving equations that involve algebraic fractions. So that's what we're getting ready to do. Today, we're just going to talk about reducing algebraic fractions. So this has a lot in common with reducing numerical fractions. So let's talk about what it means to reduce a fraction. So, if you want to reduce a fraction, let's say we've got a fraction like 6 over 15. Frequently, a lot of people will look at this and say, oh, well, you know, 3 goes into 6 twice, 3 goes into 15 5 times, so this is equivalent to 2 over 5. Now the question is, what exactly is going on here when you divide those numbers by 3? So let me kind of try to show you what is going on here, okay? The idea is that the 6 and the 15 both share a common factor of 3. The 6 is 3 times 2, the 15 is 3 times 5. Okay, that's pretty straightforward. We recognized that when we were thinking about what did we want to divide both of these numbers by. Now, once we recognize that, we can break this fraction up into 3 over 3 times 2 over 5. So if we're going in this direction, this is pretty straightforward, right? 2 times 3 is 6. 5 times 3 is 15. But notice what we have right here. This 3 over 3 is equivalent to 1. Okay? And so this is essentially why 6 over 15 is the same as 2 over 5, is because it's just 2 over 5 getting multiplied by some form of 1. Okay? Now the reason why I want to talk about that is because frequently, in doing algebra, people see an algebraic fraction or a rational expression that looks like this, you know, and they see the 7 and the 21 and they say, oh, all right, I know, I can reduce those. 7 goes into 21. I can reduce that. But notice that the 7 and the 21 are not being multiplied. They're being added. Totally different situation. Okay? This fraction is in lowest terms. Now, if you had something like, 7x over 21y, then yeah, sure. You could split this up so that you've got a common factor of 7. 7 over 7 is 1. And so this would reduce to, that's supposed to be times. This would reduce to x over 3y. All right, because what's happening between the 7 and the x and the 21 and the y is multiplication. And so this is all about 7 over 7 times x over 3y. That's not what's happening here. This can't be reduced. This can because it's all about multiplication. That's a fundamental idea when it comes to reducing fractions to lowest terms, is that it's all about multiplication. Okay. Let's see here. So there's an example in the textbook on page 50 that's similar to the one that I just showed you. So let me write that one up here. So this is the one I was saying can't be reduced. That's in lowest terms. On page 50 we have this fraction 21x plus 14 over 7x plus 7. Okay, Now we can't just go and cancel the 14 and the 7, okay? But what we can do is try to identify factors for the numerator and factors for the denominator. All right, in both cases we have a common factor of 7. So on top we get 7 times 3x plus 2. On the bottom, 7 times x plus 1. We can just cross out those 7's, but I'm going to write this out the long way just to make the point, right, that this is equivalent to 1. So that this fraction right here actually does reduce, and in lowest terms, it'll be 3x plus 2 over x plus 1, and then that's lowest terms for that fraction. Okay, let's see, what else? Let's see, at the bottom of page 51, we have an example, 16 minus x squared over x squared, that's supposed to be a 2, there we go, plus x minus 20. Okay, so the main question, whenever we get a problem like this and we want to reduce it to lowest terms, what are the factors on the top? What are the factors on the bottom? That's what we want to know. Okay, so on the top, this is a difference of squares. It factors as 4 plus x times 4 minus x. And if you multiply this back through, you'll get a positive 16 and a negative x squared. And those two middle terms, the plus 4x and the minus 4x, cancel each other out. Okay, down here this is a trinomial. Factors of 20 that have a difference of 1 are 5 and 4. So this will be x plus 5 times x minus 4. So we actually don't have any common factors, okay? These are all technically different factors. Now you might be looking at these two and saying, well, isn't there something I can do with them? So let's talk about that. There is something that you can do with them. Now remember that when we cancel something out, it's because it's the same, right? Let's say that we had something like, x squared minus 9 over x squared plus 5x plus 6. This is x plus 3 times x minus 3. This is x plus 3 times x plus 2. These cancel out. And in lowest terms, that fraction would be x minus 3 over x plus 2. These are the same. That's why they cancel out. They're exactly the same thing. And so if we think of this as x plus 3 over x plus 3, that's equal to 1. That's why we canceled it out. We don't have that situation here. None of these are the same. All right? We don't have a common factor that is equal to 1. Right? Okay. But what we can do is take these two, 4 minus x and x minus 4. Now, they're not the same. This 4 is positive, this 4 is negative, this x is positive, this x is negative. They're not the same. But what we can do is, let's say we take the top one and we factor out negative 1. That's going to leave a negative 4 here and a positive x there. And if we turn these around, then we'll have a positive x minus 4 on the top and a positive x minus 4 on the bottom. Now they are the same. Now they are a common factor and they cancel each other out. And so this thing that we're looking at right here, it's not equal to 1 the way that the factors that are exactly the same are equal to 1, but it is equal to negative 1. Okay, so if we want to go back to our original problem and we want to cancel these factors out, we have to replace them with what they're equal to, which in this case is negative 1. Okay, so we can answer this problem. We can say this is going to be negative parentheses 4 plus x over x plus 5. And you have to put the parentheses there. If you just write minus 4 plus x, then it's wrong. It's different, okay? Let's see. What else can you do for this answer? You can also write this with a negative out in front of the fraction bar, okay, then you don't necessarily need to have those parentheses up on top. You've just got a negative out in front. You can also put the negative on the bottom, so long as you have parentheses. Or, if you don't like the parentheses, distribute that negative inside the parentheses. These are all the same thing. They're all correct. Okay? And what is not correct is if you put the minus without parentheses, or if you put a minus on the top and the bottom. That's also not correct. All right? So, that's some examples for reducing these algebraic fractions. Let's go over to the problem set and look at some example problems there. So let's see here. This is on page 56. These are the exercises for section 1.6. Let's start with number 2. We've got 4x squared plus 8x over 12x plus 24. Now don't get sucked in here and try to cancel the 8 with the 24. You might be able to get away with that in this problem if you did it exactly right. But the best thing to do here is just find the factors of the top, find the factors of the bottom. On top we've got a common factor of 4x, and that would leave us with x plus 2. And on the bottom, let's see, we've got, oh, I think I wrote this down wrong. 12x plus 24. So there we go. Okay. Here, what do we have? We've got a common factor of 6, and that would leave us with x plus 4 inside the parentheses. Oh, that's not right. We've got a common factor of 12. There we go. And that leaves us with x plus 2. Okay, now that I've identified the factors finally, let's see. These x plus 2's cancel each other out because x plus 2 over x plus 2 is equal to 1. Over here, the 4 goes into the 12 3 times, and we end up with just x on top and 3 on the bottom, x over 3. All right, let's see here. Problem 4. We've got 15x squared plus 24x on top and 3x squared on the bottom. Okay, so again, on the top we want to identify any common factors we've got. Let's see, these are both divisible by 3. They both have a factor of x, and this would leave us with 5x plus 8 on the top. On the bottom, these are all factors. This is being multiplied, so we don't need to really worry about it too much. Anything that's happening down here is happening through multiplication. So we can cancel those 3's out, and the x goes into the x squared. It cancels out one of these two x's and leaves another one. So this is 5x plus 8 on top and x on the bottom. Now these x's don't cancel because this 8 doesn't have an x, right? This x is not a factor of the whole numerator. That's why you can't cancel those x's out. So this is lowest terms, 5x plus 8 over x. Okay, let's see here. Oh, I want to do an example that's not in the textbook because I want to illustrate something for you. So this example is, what if we have x plus 2 on top and then x squared minus x minus 6 on the bottom? Well, the x plus 2 on the top, that's it. That's a prime factor. It can't be broken down, okay? So it's going to stay like that. On the bottom, this is a trinomial. We need factors of 6 that have a difference of 1, and that'll be 3 and 2. We need x minus 3 times x plus 2. So those two cancel each other out. Now we're left with an x minus 3 on the bottom, but the question is, what's left on the top? Well, remember that if you cancel a fraction and you have nothing left on the top, you actually have a 1. Okay? So this one in lowest terms would be 1 over x minus 3. And that's really important because 1 over x minus 3 is very different from x minus 3 itself. Okay, let's look at a couple more examples here. Let's see here. Problem 6. We've got x squared plus 4x plus 4 over x squared minus 4. So, number one, I can't say this enough times, do not try to cancel things in this form. You cannot cancel those x squareds, you cannot cancel any of these 4's. What you have to do is figure out the factors of the top, the factors of the bottom. Okay? The denominator is a difference of squares. It factors as x plus 2 times x minus 2. On the top, this is a trinomial, and it's going to factor as x plus 2 times x plus 2, right? There's our x squared. 4x is coming from 2x and 2x, and then 2 times 2 is 4. These x plus 2's are common factors. They cancel each other out, and we end up with x plus 2 on top and x minus 2 on the bottom. That's lowest terms. You can't cancel the 2's. You can't try to do the negative one thing with this. This is lowest terms. You can't cancel out any common factors. Okay, so this one just ends up being left like that. Okay, let's see here. Let's look at problem 10. Problem 10, we start out with x minus x squared on top, and then x squared plus x minus 2 on the bottom. So again, what we need to do is decide what are the factors of the top, what are the factors of the bottom, and do they share any factors in common. All right, on top, notice there's only 2 terms here. That means it's not a trinomial. These 2 terms share a common factor of x. If you factor that x out, you'll be left with 1 minus x in parentheses. Okay. On the bottom is a trinomial, and we want factors of 2 that have a difference of 1. Well, that's easy. That's 2 times 1. If this is going to be a plus, that means we need the 2 positive and the 1 negative, right? There's our x squared. There's the 2x minus 1x leaves us with positive 1x, and then 2 times negative 1 is negative 2. So again, just like that example I was showing you a little while ago, we don't have any common factors here, but, right, we can cancel these out because 1 minus x over x minus 1 is equal to negative 1. So, I'm going to call this negative x over x plus 2. And in that other example, I talked about the other forms that this answer can take, right? You can put the negative sign out in front, and so on. Okay, let's see here. Let's look at one more of these. Problem 12. This one we've got 2x squared plus 5x minus 3, and then on the bottom, 1 minus 2x. So again, we want to know what are the factors on the top, what are the factors on the bottom. On the bottom, we don't have a lot of work to do. This is prime, it can't be factored. All it can do is cancel with something else that's like it. Okay? Up on the top, the 2 and the 3 are both prime. We don't have a lot of options for how they're going to factor, but we need to decide, do we want to do this or do we want to do this? Now remember, we need to get a difference of 5. So if we set it up like this, we would get 2 plus 3 makes 5. That's not what we want though. We need a difference of 5. That's why we need to switch these. Put the 3 here, put the 1 here. Now you get 6 minus 1 is 5. We want the 6 positive, we want the 1 negative. Okay? And again, now notice that this sets us up to cancel this. You've got 2x minus 1 here, 1 minus 2x here. These cancel, make negative 1, and so our answer is negative 1 times x plus 3. If you want to distribute that negative inside the parentheses and call it negative x minus 3, that's fine as well. Okay, so that's all for today. We're going to do the rest of section 1.6 in another video. There'll be a separate quiz for that, and I will post that once I get it done. Thanks.